In this video, we're going to look at the Lewis structure, molecular shape, and hybridization for sulfur monoxide. And as you can see, some of it's already been done. So we'll just kind of go over what I've done. The sulfur monoxide, that's 6 valence electrons for the sulfur, 6 from the oxygen, and so 12 valence electrons total to account for in our diagram. How I arrived at that shape was I had my sulfur and my oxygen. There's no central atom in this case. I'm going to have at least one bond between them, and then I can complete the octets of the outer atoms. 2, 4, 6, 8, 10, 12, 14. Oh, I see there's a problem. I've drawn too many electrons. I'd only have 12 electrons to draw, so let me erase that. And now you can see that the oxygen is not happy. It does not have its octet filled. It would if I put in a double bond here, which means that I would have to remove a lone pair from the sulfur. And so that's how I arrived at the shape that I've already drawn. And sometimes, just to point out, you wouldn't draw these lazy lines to indicate two electrons or a lone pair. Sometimes you draw little X's or dots, and sometimes they're drawn at an angle just to sort of show that they're trying to minimize repulsion between them. Okay, and down here on the bottom left, I've already drawn sulfur. Sulfur's valence electrons in its ground state. So it has 6 valence electrons total, arranged like so. And now we have to figure out what kind of hybridization this is. Well, from the diagram we've drawn, we see that there's 3 regions of electric charge. There's 2 lone pairs and a double bond. So 3 regions of electric charge. That corresponds to sp2 hybridization. And again, that means that 2 of the p orbitals will hybridize and 1 of them will not. So to draw that out, we end up with 3 hybrid orbitals and the p orbital that does not hybridize. There's our 6 valence electrons drawn in. Okay, well, we're just focusing on the sulfur here, but what we'll do is we will fill in the valence electrons from the oxygen as well. Well, these orbitals are full. Okay, so these are going to be the lone pairs on the sulfur. And then this orbital will place one of the valence electrons from the oxygen, and this orbital will put another valence electron from the oxygen. These are the valence electrons that are being shared from the oxygen. Okay, and we've learned before that a double bond consists of a pi bond. Sorry, that's a sigma bond I drew there. A sigma bond and a pi bond. This would be the sigma bond. It's a lower energy orbital. And this here would be the pi bond. That's between the electrons in the p orbitals.